Okay, guys, here we go. Day 3, normal distribution and z-scores. All right, so I'm just going to read what I have written here and then I'll talk about it. It says many populations have a distribution that can be well described with what is known as a normal distribution or the bell curve. The curve shows the percent or proportion of a normally distributed data set that lies certain amounts from the mean. Okay, so what is this chart? If we were to look at things like SAT scores with kids, most kids are going to score in the same range. No matter how many times they take it, maybe up or down a little bit, but most of you guys are all going to get around the same scores. And then there's going to be, I don't know, some genius that winds up, getting a super duper score that's like close to a 1600, right? And then sometimes there might be kids who just don't do as well and they wind up getting a really, really low score. So SAT scores can be used and modeled with one of these normal curves. So if we were to look at the percentage of kids that get that super high, crazy grade, close to a 1600, you notice that the percentages are very, very small. And if we were to look down here at maybe the percentages of kids who do awful on the SAT, it's also going to be pretty small. But smack in the middle, you can see most of the data lies. And that's where most of you guys would be with your scores. Now, we can also use this to model things like weights as well. Most kids around the same age, teenagers, based on your gender, are all going to be like around the same weights. Same thing with heights, right? So most of us are going to be around the same, and then you're going to have the people all the way to the right where it'll be just a few, kids that are really tall, and then a few all the way to the left would be, really short. And if I had you guys line up in class and we did this, we would see that we would get something like this. Okay, so we'll elaborate more on those percentages and what the numbers underneath are, which are the standard deviations, which we talked about yesterday. All right, so let's take a look. I'm giving you one little example here with heights. Okay, so height of North American men. And you can see the average, like I was just saying, is right in the middle there. 68 inches, so that would be 5'8". And then 70 inches, that would be 5'10". So it makes sense about, I think the average height of a guy is somewhere between 5'8" and 5'10". And then we got our crazy NBA players over here, right? And then maybe we have some of the jockeys over here, right? So really tall guys and really short guys. But most are going to be around the same. So most of our data is going to lie in the middle if things aren't normally distributed. And I did put some other things over here too. Heights, like we just said, weights, like we said, temperatures or something as well. Throughout the year, usually our temperatures are about the same, but then we might get that like crazy warm day in the winter, or we might get that like freezing day. Like today's a little cold. There was a little snow coming down here at my house. When it should be warm. IQ scores or something again, most of us are going to have around the same IQ scores. And then we're going to have the geniuses, and the geniuses are going to be all the way out here, but there's not that many of them. And that's why if you look up above, what our percentage is, there's not going to be that many people that have that crazy high IQ, or the people that, unfortunately have low ones. All right, and light bulbs burning too, like in industry, if when you're buying products, it does tell you how long something might last, batteries too. Okay, so let's take a look at this. So it says, so we can understand more what these percentages and all these numbers are. It says for a population that is normally distributed, and that's going to be our key phrasing here, okay, normally distributed. Anytime we hear that, we're going to think of the bell curve, okay, which is right here. Find the percentages of the population that lies within one standard deviation of the mean. Okay, so that means we're going to go back up, and I'm going to go back and forth between these. Let me erase all this stuff so I could keep using it. Okay, so if we're going to go within one standard deviation of the mean, this is where your mean always is, right here. This is where your X bar is, right here. Now, if I go one deviation below the mean, X bar minus one deviation, right? That's going to be these percentages. And if I go one deviation above the mean, that's going to be these percentages, and I add those up, I get 68.2% of the data. So most of the data is going to lie within 68.2% of the data is going to lie within one standard deviation. And you notice these are just half deviations too. Okay, so that's why we'll write the 68.2%. Okay, and you can see that I also put that in down here, 68.2%. Now what happens if I go within 2 standard deviations of the mean? Okay, so we can just use this guy now. We can look here. So if I go 2 standard deviations of the mean, that means I'm going to use all these percentages to be below and all these percentages to be above. And if you add up all those percentages, right, you can see here's my 2 deviations, I get 95.4%. Okay, so 95.4% is going to be within 2 standard deviations of the mean. Remember, to deviate is just to go away from. And then if we went out 3 deviations, right, here's 3, so we would just add up all these percentages. And if we add up all those guys, we wind up with 99.8%, which makes sense. I mean, the further you go away from the mean, you're going to be getting all of your data. All right, so now what are percentiles? So let's look at this. A percentile rank, and we spoke about this yesterday, a percentile rank is the percentage of scores that fall at or below a given score. So if you fall in the 90th percentile for height, it means that you are very tall. If you fall in the 10th percentile for height, it means you're little compared to the rest of the people. And if we lined up 100 people, and you were in the 90th percentile, you would be number 90, with 100 being the tallest. Okay, so how do we get percentile rankings? Here's how we get the percentile rankings. So we take those percentages and we add them. So if I add these 2 numbers right here, those 2 percentages, that adds to 0.1. Oops, not that guy. Sorry. Whoops, just that guy. We wind up with 0.1. Now, as I keep adding, right, so let's say that I add that first one. Oops, I meant to get the highlighter. The second one, right, the third one, right? If I add up those 3 numbers, I'm at the 2.3 percentile ranking. Now keep adding. I add these 2. Now I'm at the 15.9th. And if I add these 2 along with it too, so all those yellows, now I'm at the 50th percentile. Keep going. I add up these. I'm at the 84.1st percentile, and so on. And you just keep adding. So you start at the bottom. That's why I have this arrow here. To find a percentile ranking, you always start at the bottom, adding. Okay. Alrighty. It says normal distributions are very useful when analyzing data. It allows you to calculate the probability of an event happening as well as the percentile ranking of scores. Okay, so that's what we're going to look at, all different kinds of questions we can do using this little chart. All right, so before we start our second question, let's look off to the right. So far we've been using X bar. X bar is generally used when you have a sample mean. But mu, that's what this symbol is right here. This is called mu. This guy is used as well, and this is for a population mean. Okay, so both of these will be used. All right, so SAT scores are approximately normally distributed. The mean for the combined SAT is 1017, and the standard deviation is 210. All right, so I'm just going to write this off to the side. So we have a mean of 1017. And again, if you can use either one of these symbols. When we get up to AP Stat and everything, I think that it'll count more there which one you use. But our calculator uses X bar, so that's why I'm just going to keep using X bar. But I wanted you to see the mu because sometimes you can get an example where they're using that symbol instead. But again, our calculator just uses X bar. And then our standard deviation is 210. Okay, so what did I do? I put my mean where it belongs, right in the center. And then I added 210, so that's how I got this guy. I added another 210, added another 210. Subtract 210, subtract 210, subtract 210. Okay, so it says draw a model for the SAT scores. That's what I did here. Clearly label it showing. So what is this? Well, they're rounding, but 68.2%, remember, is your one deviation each way. 95.4% is two deviations each way. And 99.7 is three deviations each way. So that's all they're mentioning there. Okay, so they want to know what percent scored between 807 and 1227. Okay, so find those values. I don't know why I can't make this like thicker today. It's so weird. All right, so I'm just going to make little circles here. So 807, right, to 1227. So this is where I'm looking from. So where am I looking from? One deviation each way, right? So one deviation each way we have memorized as 68.2%. And that's our answer for the first part. Okay, next one. What percent scored greater than 1437? Okay, so now we have to go up here, back up here, greater than 1437. So greater than 1437 is going to be two deviations or higher. So if we go back to our chart, two deviations or higher, and I add up these percentages right here, that's going to be my answer, which is 2.3%. Oops. Okay, so 2.3%. Now, why all of a sudden did that get thicker like I wanted it? What happened? That's weird. Okay, good. All right, what percent of the students scored less than 807? And now this question really is looking for what's called the percentile ranking because we're coming from the left up. But let's take a look. All right, less than 807. So less than 807 means I'm looking at everything here that's going to fall less than 1. So let's go back up to the top again. And we could add up which percentages again? These guys right here. So less than 1. So I could add up all of these. And if I add up all of those, remember how we did it before, going this way? I wind up at 15.9. All right, so don't get too crazy if you know this is a little rough because tomorrow I show you how to do all this on the calculator, so you don't really have to memorize everything on that chart at all. It would be helpful if you memorized that one deviation each way is 68.2% and two deviations each way is 95.4, but that's pretty much all you have to memorize for me because the rest of it I'll show you how to do like all of it on the calculator, so don't worry. But we like to just show you on this first day how to do it without. Okay, the scores on a standardized test are normally distributed. So what are you thinking again? As soon as you see normal distribution, you're thinking of the bell curve, where most of the data falls in the middle, and then some weird stuff out here, not that many, and some out here. All right, with a mean of 76. So I made the little graph already for us so that we could, it could be neat. So I don't have to keep zooming in and out. So the mean is 76, and then the standard deviation is 4. So again, maybe like you want to take this information out to the side. So let's go back, and if I want to add on one deviation, add on a second deviation, right? You're just adding 4. Subtract 4, subtract 4. And it says between what two scores will 68.2% fall? So between which two scores? So 68.2% means one deviation each way. So that's this. So the answer would be 72 to 80. So that's the answer to the first part. Then it asked me for 95.2%. So 0.4%. Well, that's going to be 2 deviations each way. So that's going to be 68 to 84. And that's going to be my second answer. And then which scores, oh no, that was it. Okay, good. All right, number 4. Again, I made the graphs ahead just so they could be neat. On a standardized test, a score of 82 falls exactly 1 standard deviation below. So that's going to be this one, right? 1 below. But if the standard deviation is 4, right, how do we find the mean? Well, add 4 to this, and we got 86. So choice 4. All right, the heights of 16-year-old teenage boys are normally distributed. What does that tell you again? Bell curve. With a mean of 66 and a standard deviation of 3. So I like to make these little graphs here. So the mean is 66, and then the standard deviation is 3. So why did I go above? Because if we read the question, it says if Jabari is 72 inches tall, so I want to get to the 72 inches. Which of the following is closest to his percentile ranking? Okay, so percentile ranking means I'm going to start at the bottom, right? And I'm just going to add up all those percentages for now. Tomorrow I'll show you how to do it in the calculator. So let's go back to this guy. And I'm just going to erase some of this. But again, we'll do this on the calculator tomorrow, so don't worry. All right, so he was 2 deviations above. So if I want to find out his percentile ranking, I'm going to start here and add up all the numbers until I get to here. So all these percentages until I get to right here. And if I add up all those percentages, we get close to, well, we had 97.7, but the closest choice is 98. All right, so percentile ranking. But don't worry, we're not going to have to memorize that chart. Okay, in a normal distribution, 68% of the scores fall between 72 and 86. So you just need to know that that's 1 deviation each way. So that's why this is 72 and this is 86. And then they tell me that the mean is 79. What's the standard deviation? Well, how far did you go this way? And how far did you go this way? So my standard deviation is 7. All right, one more concept to teach you here. It's what's called a z-score. So not all data, falls exactly 1 deviation above or exactly 1 deviation below or exactly 2. They all could be decimal values, and that's why we're going to use the calculator eventually. So a z-score, so let's look. It says for a data point, x sub I, so that's just the data point. Maybe that's the 1200 you got on the SAT, but that's what a data point is. Or maybe it's that your height is 5'8". So the data point is the one piece of information we have, and we want to see where it falls. The z-score is calculated by using this formula here. So the z-score is like your score minus the mean, and then we divide it by the standard deviation. So the z-score calculates how far from the mean in terms of standard deviations a data point lies. And it could be positive if it's above, or it could be negative if it's below. Okay, so that's what a z-score is. Okay, the normal distribution can be used in increments other than standard deviations. That's what I said, so that's why we need to have this formula. So let's check out using this, and then we'll talk about what the z-score means in context of like doing a question here, so you'll probably better understand it. Okay, it says boys' heights in 7th grade are normally distributed. Again, right there, you guys are thinking of the bell curve. With a mean of 62, a standard deviation of 3.2. They want you to find the z-score of a boy who is 66 inches. So that's our data point. Okay, so as you can see, like I like to take this formula right here, and I like to put it in words instead. So I like to say that the z-score is the score, but remember, that's going to be like our data point. It's either your SAT grade, your height, minus the average, and then divide it by whatever the standard deviation is, and that'll give you your z-score. Okay, so we're going to use that formula. You want to use the traditional one up there, you can, or you want to use the one in words, you can as well. Whatever you like. Okay, so let's try and find the z-score. So it's going to be the score, or the data point, minus the mean, divided by the standard deviation, and we wind up with a z-score of 1.25. So what does that mean? His z-score is 1.25, right? What does that mean? It means that he falls 1.2 deviations above the mean. So it means that he's a little bit taller than average, to be 1.25 deviations above the mean. Okay, and in this particular question, where the average was 62 inches, right, and the standard deviation was 3.2, right, that means that what? Most of the data, right, most of the kids are going to be 3.2 inches above 62 and 3.2 inches below 62. That's going to be the range where most of the kids are going to fall. And then this kid actually winds up falling a little bit above that. He's 1.25 deviations above. So he's a little bit taller. All right, let's try another one like that. So Jeremiah took a standardized test, and the mean score was 560. The standard deviation was 45. And now this time, I'm giving you the z-score. Okay, so he fell 1.84 deviations above the mean, so he was a little bit higher. Then what we want to know is, what was his score? Okay, so we're just going to work backwards here. So let's write the formula. The z-score is going to be the score, which is the actual data point, minus the mean, divided by the standard deviation. Okay, so the z-score, so the actual, oh, whoopsie, we know the z-score. Okay, so the z-score, 1.84. Now the score is what I'm trying to find, so I'll just name that x, minus the mean, divided by the standard deviation. And then I'd be asking you, all right guys, how do we solve this? And hopefully people will be telling me proportion. So we'll cross multiply and set those cross products equal. So 82.8 equals x minus 560. And x equals 642. I need more room. 642.8. Oh, sorry. I don't think I saw that equal sign. Yeah, add 560 to both sides. And 642.8 is going to be my x value, which would be my score. Okay, so let's see, does that make sense? That Jeremiah's score, we need to go round to the nearest whole number. So 643, right, nearest whole number right there. Okay, so does that make sense? Well, let's see. So the average was what again? The average was 560, and he was above, right, 1.84 deviations above, so 643, which makes sense. He would be higher. All right, goody, we're done. All right, so here's your homework. You guys are going to do those, and then I'll upload an answer key for you to check. All right, I know this is rough, and this is really something I wish I was in front of you teaching, but you do the best you can. You follow along with me, pause it, rewind, send me messages, and I'll try to explain as best I can to you. And I will definitely try to, not be making things too difficult. All right, bye.